Einstein's equations say there should be objects that spit out everything a black hole swallows. Not pull in. Push out. A drain run in reverse. The same math that gave us black holes quietly predicts their mirror twin, and in over a century of looking we have never found a single one. Not one candidate that holds up. So tonight, one honest question. What if black holes have an opposite we've never seen? Start with what we are sure of. You already know how a black hole behaves. Gravity wins so completely that past a boundary called the event horizon, every possible path leads inward. Light, matter, time itself, all of it falls one way, and nothing climbs back out. For decades that was theory. It isn't anymore. In 2015 we heard two black holes collide, the shock of it rippling through space-time as gravitational waves. In 2019 the Event Horizon Telescope photographed the glowing ring around the giant black hole in galaxy M87, and in 2022 it imaged the one at the center of our own Milky Way. Black holes are real. We have seen them, heard them, and mapped them. But here is the strange thing about the equations that describe a black hole. They don't care which way time runs. The mathematics of general relativity is time-symmetric. You can play it forward or backward and it stays valid. So if you take the solution for a black hole and simply reverse the direction of time, you don't get nonsense. You get something that is still a perfectly legal answer to Einstein's equations, a solution that has been sitting in the theory, fully formed, for over 100 years. That reversed answer is a white hole, and it is the exact mirror of a black hole. Where a black hole is a place you can enter but never leave, a white hole is a place you can leave but never enter. Matter and light pour out of it. Nothing in the entire universe can fall in. There is still an event horizon, still a boundary, but it works in reverse. Try to approach, and the relentless outflow pushes you away before you ever reach the edge. It is, in the purest sense, a black hole running backward in time. And this isn't fringe speculation or a modern invention. In 1960, the physicists Martin Kruskal and George Szekeres independently worked out the full geometry of the simplest possible black hole, the kind described by Carl Schwarzschild back in 1916. When they extended the math as far as it would go, the complete picture didn't show one region. It showed four. Our universe, a black hole region, a second universe on the far side, and a white hole sitting on the other side of the singularity like a reflection you never knew was there. Tucked into that geometry was also a bridge between the two universes, what we now call an Einstein-Rosen bridge, a wormhole, one that can never actually be crossed. The white hole was never bolted on. It fell out of the equations on its own. So, picture it for a moment. A point in space from which a river of gas and radiation streams outward forever, and toward which nothing can ever fall. A cosmic spring instead of a cosmic drain. If even one of these existed anywhere nearby, it should be one of the brightest, most violent, strangest objects in the entire sky, impossible to miss, which raises the obvious and uncomfortable problem. We have built the telescopes. We have searched the gamma-ray sky, the radio sky, the X-ray sky, and we have never, with confidence, found one. And the deeper you look, the worse it gets for the white hole. Because there is a real, physical reason the universe might simply refuse to make them. Back in 1974, the physicist Douglas Eardley pointed out a fatal flaw. A white hole is wildly unstable. The moment any stray matter from the outside universe drifts toward it, even a faint pulse of light, that matter gets trapped against the outflow, piles up just outside the horizon, and collapses under its own gravity. The result is brutally ironic. The infalling shell forms its own event horizon, and the white hole is buried inside a brand new ordinary black hole, almost instantly. In a universe full of stuff, a white hole seems to turn black the moment it is born. There's a second objection, and it cuts even deeper. Thermodynamics. The second law says disorder, entropy, almost always increases. A black hole is the ultimate expression of that. It is the highest entropy object we know. A white hole would do the reverse. It would take a smooth, hot, high entropy state and spit out structure and order, like watching a shattered glass leap back onto the table and reassemble. It looks like the arrow of time pointing the wrong way. So between the instability and the thermodynamics, a lone white hole seems to have no way to survive long enough for us to ever catch one. So is that the end of the story? A beautiful solution the cosmos simply chooses never to use? Maybe not. And here is where it gets interesting. Because everything we just said assumes pure classical general relativity, and we already know general relativity cannot be the whole truth. At the very center of a black hole, the theory predicts a singularity, a point of infinite density where the equations stop making sense and physics itself breaks down. Almost no one believes the infinity is real. Most physicists think a deeper theory, a theory of quantum gravity, takes over in that tiny core and prevents it. And that is exactly where the white hole quietly gets a second life. In one of the leading proposals, the physicist Carlo Rovelli, working with Francesca Vidotto, Hal Haggard and others in an approach called loop quantum gravity, imagines that collapsing matter never actually reaches a singularity. Instead, it crushes down to something they call a Planck star, a core compressed to the smallest scale physics allows, where quantum gravity slams on the brakes with a pressure nothing can overcome. And then, instead of vanishing forever, it does something astonishing. It bounces. The black hole quantum tunnels into its own mirror image. It becomes a white hole, and everything it once swallowed begins, finally, to come back out. And here is the detail that makes the whole idea haunting. Time. Near that crushed core, gravitational time dilation is so extreme that the entire bounce could feel almost instantaneous from the inside, a fraction of a second, while the outside universe waits billions of years for it to play out. Think about what that means. A small black hole that formed in the first instance after the Big Bang might, only now, after the entire history of the cosmos, be flickering over into a white hole, releasing whatever it once consumed in a single, brief, ancient breath of light. The bounce isn't slow. We are just watching it from very, very far away in time. That idea comes with tempting hooks. Some researchers have asked whether a strange, unexplained burst we have actually recorded could be such an event. There was one famous gamma-ray burst, detected by NASA's Swift satellite, that broke all the usual rules, long in duration, but with no exploding star behind it. A couple of physicists openly wondered in print whether it could be the signature of a white hole switching on. Others have proposed something quieter and stranger. That tiny white hole, remnants, each one no heavier than a speck of dust yet smaller than an atom, could be drifting through the galaxy by the billions, invisible, quietly making up part of the dark matter we still cannot identify. A few have even speculated that our entire universe began as the outflow of one enormous white hole, the Big Bang itself as the ultimate cosmic spring. But honesty demands the hard line. And here it is. Every single one of those ideas is speculation built on a theory of quantum gravity we do not yet possess and cannot yet test in any laboratory or telescope. There is, today, not one confirmed white hole anywhere in the observable universe. Not one. Every candidate that has been proposed has turned out to have a more ordinary explanation. The white hole remains exactly what it has been since 1916. A flawless, self-consistent answer to Einstein's equations that nature may, or may not, have ever actually used. And maybe that is the real awe here. The same equations that gave us black holes, objects we've now seen, heard, and photographed across the sky, also hand us a perfect twin we may never find. The math is scrupulously honest. It offers both doors. The universe, so far, has only ever shown us the one that leads in. Whether the other door has opened, somewhere, sometime in all the vastness of space and all the depth of time, is a question we genuinely, at this moment, cannot answer. If you want the cosmos told straight, what we have actually verified, what is still only theory, and what is honestly unknown, subscribe. This channel publishes the honest cosmos every week. One question before you go. If a white hole truly cannot be entered from the outside, not by anything ever, then where does everything it pours out actually come from? Tell me in the comments.